pumpkin. All right, Michelle, lucky number 1. Denise, we got second lucky person today. Ooh, look at those beautiful colors. Andrea. Yeah. Very nice. Okay, so geologic conditions that create the Namib Desert. And these, by the way, go for pretty much all the main deserts we've seen. So, Michelle, tell us, go ahead, lecture the class on why there's a desert here, please. Oh, okay. All right. What's your guess, Michelle? So there's a storm. So it doesn't rain for years and years and years. Is that probably because of one storm? No. And storms come and go, right? So this is a persistent lack of water and moisture from the air. Okay? You got another idea? That's it. I mean, that's it. I mean, the storms do affect, when it's stormy, it gets rainy, right? So, I mean, it's a good guess. Any other ideas? Something about what's going on here. No. All right, Denise can help. Denise, what's your thought on this question of the day? Ah, yes. One of the big ones is there's a cold ocean current that goes, I have no idea if it's north or south, but I do know here. So the current goes here, and it's the Bengali current. Okay. Actually, I got to double check that. I'm not sure if it's Bengali. Bengali might be coming from north. But I do know that ocean current that goes from the south to the north, that's a cold current. Does water evaporate very well off of cold water? Anybody? Does water evaporate better off of warm or cold water? Warm water. Yeah, cold water, just like what we have here, you don't get as much evaporation. So you don't get you get fewer rain clouds from this air. So this air, you don't have a whole lot of rain clouds. If you look at the other side of Africa, Andrea, what do you see? Well, like over here, what do you notice along that coast? Well, what color do you see on the other side of the coast? It's very dry here in the desert. Over here, well, you see a little patch of green, don't you? So the air that's coming, the air direction is generally this way. It's there's some little mountains over there. It's called the escarpment. Yeah, I remembered. That's great. You can't even see that there. I'll write it here. So the escarpment, those are mountains. Let me try to slow down a little bit. The escarpment mountains, and this would be southeast Africa. Strip moisture from the air. So by the time that moisture gets over to the Namib Desert, there's not much moisture in it. So it's like a rain shadow effect. From the videos, I give you a bunch of examples of rain shadows. This is like a rain shadow. So it is in somewhat of a rain shadow. So there's some rain shadow effects happening there too. not only these other things, there's something else happening. And Andrea, I think you did have it written. What was the thing you wrote about that also creates this dry climate? Yeah. So the air is under high pressure. If you remember from the video, the diagram from last week, you have cold, dry air coming down, okay? And that cold, dry air that's descending on the land doesn't carry much moisture, so those areas are dry. So that's 30 degrees north, 30 degrees south of the equator tend to be fairly dry because of that. And those are called Hadley cells. Yeah, you're thinking the Hadley cells. Cold, dry air descends, no moisture. So it's dry. So you got a lot of things going on there, none of which help the water situation, right? Make it drier and drier and drier. Okay. When you get done writing that, I want to finish up the FRQ we were grading together on paper last week on Friday. It was at Aquifer. I think we finished the second page, right? But we haven't talked about the third page yet, about this test. Yeah, listen. You don't have this? Okay, let me see. See if I got extras. I think you got it before Friday, didn't you? Or no, just Friday? Anybody else not have it? FRQ, topic 4, FRQ practice 1. Everybody else has theirs? All right. All right. Okay. Everybody with me? So I got this long little blurb for part C of the question. So let's take a look. They're worried about site B, sedimentation in the river. What is sedimentation? Like what's happening if you have sedimentation in your river? What's going on? Too much sediment. What is sediment? Bit smaller than rocks. Fine dirt particles. Yeah, like sand, silt, and clay would be part of sediment. So let's just find that settle in water. All right, so we're worried about fine dirt. Because if you mess with the area next to a stream, you're going to disturb the soil. When it rains, it's more likely that water is going to carry dirt off the land into the water. And that's something you don't want. If you're a fish swimming around, oh, this is nice clean water. And then it becomes all silty and sandy and cloudy, that's not good, right? Not good. Not for your gills, not for the plants. You don't want to have that. So there's this site B. They're worried about it. So they hire a company, do a study. They mark out a plot at point B and then point C. Now, B is that agricultural land They're both identical except that C is undisturbed forest. So B equals the farmland. C is basically regular forest. Undisturbed forest. So rain gauges, they want to know how much it rained. And then devices that collect eroded soil were set up along the downslope edge of the plots. So they're keeping track of how much it rains, and they're keeping track of what? They're measuring as well as they can how much dirt is washing off that land into those gauges. You guys know what a gauge is? On an automobile, how do you know how fast you're going? Speedometer, that's a gauge. How do you know how much gas you have? Gas gauge. Okay? And should you always run your car on almost empty? No, absolutely not. Don't do that. It's hard on your automobile. My son does that. I tell him, caution him strongly not to. I said, don't do that, Ivan. Fill up the tank. But you know, people don't want to put more money than they have to in their car, right? They want to keep it. But you want to fill it up. All right? He almost ran out of gas on a trip recently from doing that business. All right. But gas is expensive, so let's see. So they're measuring how much soil comes out. Okay? They figure, is it a acceptable hypothesis that more soil will come off the farmland than the undisturbed forest? Is that reasonable to assume that? Well, farmland, you plow it, right? You disturb all the soil, you grind it up, plant stuff. Is that going to leave dirt laying around? Yeah, and then when it rains, that dirt's probably going to get washed, more likely to wash into the water, right? Whereas a forest, there's stuff growing everywhere. Like right now, we have this whole area here that has the soil all cut up, right? It's all chopped up and there's nothing growing. There's bare soil. Are they doing things to manage the runoff from this property next to us so that dirt doesn't wash into the ocean? They do these days. So you look at construction areas, they'll put these big round, like big worms, big cylinders, and they'll stick them next to the site and over the storm drains to keep sedimentation down, keep it from washing off. So they figure they're going to see more dirt coming off the farmland than the forest, which is a good hypothesis. You're more likely to. That seems more likely. So they collected data with the rain gauges and the soil collection devices. So the first question is, what's the independent variable of the study? What are they measuring? What's the main point they want to determine? Soil levels coming off the land, right? So that would be, and how are they measuring that? With their gauge. They have a rain gauge. They just want to know how much it's raining. Is this study a study to find out how much it rains? No. That's not what the study's about. They're taking that data just so they have a measurement of it. Their study is all about how much the dirt washes off. So that's going to be your dependent variable, what your study is actually about. Okay? So, yeah, the dirt rain gauges, or the dirt, how do I put it? The amount of soil collected in these soil collection devices right there. Okay? Now, you guys have heard of controls in studies before? Like the main experiment we did with the saturation, the liquefaction, did we have a control? Did we have a control group? Yeah, and what was the control group? What? Well, we disturbed both boxes of sand. What was different about the boxes of sand? Sorry, was that Albert? One was wet and one was just regular, right? So in that experiment, the regular sand was our control. And then we were trying to figure out how liquefaction affects it, right? So we were comparing. We got to have something to compare to, all right? So in that case, we did have something to compare to. That's how we were able to find out if it was a significant difference or not. So what's the control? What's the control for this experiment? What's the normal level they're going to compare against? They had group B and group C, right? So it would be group C, which is the regular force, right? So the regular force, that's their control. That's how much normally there should be dirt flowing off the land. Anything above that would be a problem. So plot C is a native undisturbed soil. The natural baseline level of stream sedimentation. That's what the stream normally contends with. Okay. They received 116 centimeters. Wow, 200 kilograms of soil from plot B and 200 kilograms of soil from plot C. Here's just asking for a practice or a method that could have been used at plot B to obtain these results. Because was there a difference between the two groups? No, there wasn't, right? So it looks like they were doing something to monitor, collect, prevent that extra runoff. So does anybody have any idea the name of a farming technique that can help slow down runoff? Yes, Andrea? What's that? Oh, terracing, yes. So terracing, definitely. Anything else? Making so the water kind of slows down by terracing it. What's that? Well, there's different kind. I mean, the terms aren't landscaping, but it's kind of similar to what you see right here. So there's terracing, like Andrea mentioned. Contour plowing, you kind of go along with the hills, which creates little terraces. No-till, so you're not digging it up beforehand and letting it just blow away. Strip cropping, you basically make strips. Instead of chopping everything up, you make strips in between so there's less disruption of the soil. And then adding ground cover. So anytime there's bare soil, just throwing some kind of plant there that is benign, that won't harm your crop, that'll kind of keep the soil in place. Okay. So, there could be changes in the land to decrease erosion in both plots. And these are some ideas. Decreasing the slope somehow, making it less steep, making it flatter can do that. And that's what this describes. Runoff travels at a slower pace and have less erosive force, and therefore less erosion. And the amount of ground cover. If you have more ground cover, then you have less erosion. The plants are being held in place by roots. Okay. All right. So when you're done writing that down, I want you to, I just posted another practice quiz on AP Classroom. So go ahead, log into the Chromebooks you see in front of you and get into AP Classroom and get started on that quiz. I gave you, I think, 2 tries. So you can take it again for a higher score. So go ahead, log in on your machines and go to AP Classroom. You can start on that quiz. So with this is our FRQ practice, and you've had a couple different quizzes for the multiple choice questions, the MCQ. Study those and the videos in your notes to get ready for Wednesday. On Wednesday, you're going to have the test on topic 4, where it'll be a multiple choice section and then a handwritten free response section. Probably about 30 multiple choice questions. Then you'll start taking the handwritten part, the FRQ. Uh-huh. So, I'm sorry. We started. The other three topics? Oh yeah, we're going to move on to the other topics. There's like 8 other topics. We're just starting with 4. And we'll come back and get the other topics. Yeah, I just decided it sounded good to me.